Okay, folks. Whilst we wait for the chief to turn up, let's get started. Welcome everyone to this rescheduled working group meeting. This would normally have been on the 4th, but obviously people were busy that day. By being here, we have all agreed to the specification membership agreement, the participation guidelines, the contribution guide, and the code of conduct, links to all of which can be found in the agenda. Let's start by going through the list of attendees, go through it in the list that we are on the agenda. So I'll start with myself anyway. Hi everyone, I'm Benji. David, if you're here, you're next. You're next, Michael.
Okay, hi everyone. My name is Michael.
Hello everyone, I'm Martin from Paris, here for Apollo. And I think next is Jordan.
Sorry, just frantically trying to find the agenda. Yes, I'm Jordan. I work on Relay at Meta. I'm also taking notes from Matt Mahoney, who's not able to be here today.
Michael, you seem to be here again next.
Yeah.
So we'll move on to Ernie.
We'll skip you again here, Michael. Yeah, so I'm Ernie. I do a bunch of GraphQL stuff at Coinbase.
Hey everyone, I'm Kelvin. I work at Apollo on the iOS client. I'm out of Vancouver.
Oh, I'm Alex. I'm here as an independent.
I might be the only one left. I just submitted a PR to add myself to the attendees. I'm James. I'm in the Bay Area, work at Airbnb.
And Jeff, if you'd like to introduce yourself.
Hey, making my pull request now. Sorry I'm late. Hi everybody, Jeff Oriam at Apollo.
Perfect. Thank you, everyone. Okay, I'd love to have some volunteers for note-taking. I've started seeding the document already. A few of the topics today are mine. Everything on the schedule today is my topic. So it would be helpful if other people took notes because I don't think I'm going to be able to manage it this time. Any volunteers for note-taking, please? Perfect. Thank you, Jordan. If anyone else can help out with Jordan, especially if Jordan's talking, that would be very, very helpful. Okay, so reviewing the agenda, we've got a few short things, directive validation, an update on one of, defining the data collections and adding extensions to the request. And then we've got one larger topic, which is on semantic nullability schema. Is there anything else that anyone would like to put on the agenda for today? No? Okay, perfect. We would normally review the prior secondary meetings, but I don't think there were any back in June. I'm not aware of any, and there doesn't seem to be any in the notes document, so I'm going to assume that there weren't any. I also cancelled the secondary meetings for this month as well, since we rescheduled this one. We can have a very quick look at the meeting, at the action items. There are none marked as ready for review. Is anyone aware of any that have been updated or need closing? No, that's fine. It would be good to go through those at some point. So if any of them are on you, please do have a look at them and report back. If they're still relevant, say so. If they're not relevant anymore, let us know and then we can get them closed. Okay, so on to the main agenda. I'll hand over to myself. Directive validation. So this actually is James's topic. James, would you like to represent this one?
Sure, thanks, Benji.
Perfect.
So So it's actually been a couple months, but since I looked at it, the gist of it is to update the directive validation guidelines to be more specific that locations must be one or more locations must be specified in the definition for a directive. This is something that was implied by the grammar, but wasn't exactly spelled out in the kind of prose section of the spec. Looking at the other sections of the spec around objects and interfaces and unions and other types, they're much more explicit about, an object must define one or more fields, a union must define one or more members, and so on. So following that pattern, I updated the prose section of directives to indicate that that is the first rule. That's the short version.
Perfect. So just to give a little bit more detail, this has also been implemented now in the main branch on GraphQL.js, and it's in an open backport on the v16 branch of GraphQL.js. I personally see it as an editorial change. I'm not sure if everyone agrees with me, but I think that this doesn't need to go through the RFC process. This is effectively just a missing piece of the spec that should always have been there. So I'm happy to merge it as is, as editorial, but I'd love to get some input on that.
I second that. I also accepted the change already. Approved.
Maybe just to add some context to that, is that I encountered this when working in GraphQL Java, which actually did not have this requirement. And so adding enforcement for that requirement, that directive locations must be one or more, it wasn't like a large change, but it wasn't small either. And I suspect that there are potentially some other implementations that that actually might need some more updating. GraphQL.js was actually not one of them. It was just sort of adding a rule, but it didn't break anything. So I don't know the extent to which other implementations might be impacted, but I was somewhat surprised on the GraphQL Java side.
But the directive without location couldn't be used, right? You couldn't put it anywhere.
That's correct. But you could still, using the API, define one, or even serialize a directive without locations into STL.
Mm.
Could you pass it back though?
No.
No, it's a bug in the spec. So it doesn't need to go through the RFC process. It is definitely something that we should raise the volume on and make sure that the other implementations are aware of, and excellent work on spotting this bug in the spec. But I think as clearly a bug in the spec, we can accept it as editorial. Okay. I saw some general thumbs up across the board here. No one seems to disagree. So I will take care of getting that merged at some point in the next couple of weeks. Fantastic. Thank you, James. Okay. Next up, we have an update on one-off. So for those of you not familiar or who are watching it back on YouTube, the one-off directive is a proposed directive that you could add to input objects, which would mean that exactly one of those fields should be specified. It's a way of introducing polymorphism to input types in GraphQL, something that we don't currently cater to. It was proposed back in 2021. There were a number of other proposals that I also authored, a few of those. This is the one that sort of won out. We actually had a big comparison. I think there was 7 or 8 different proposals in the end. We had working groups about them. We weighed the pros and cons for each of them, and this turned out to be, I think, the simplest one that got the job done and was generally well liked because it was least breaking and various other nice things. And that still seems to be the case. Despite this being open since February 2021, no one yet has proposed an alternative. So I guess 3 years later, let's move ahead with it. this has been implemented in GraphQL JS. I recently backported it to GraphQL version 16, which is our stable release of GraphQL JS. And that is now actually released as of last month, I think. So that is now out in a production release of GraphQL JS. So by all means, go and use it, see how it works, make sure you're happy with it. I think it is currently, let me check the RFC tag. It's currently RFC 3 status. So I would like to move that we move this to RFC 3 status. Sorry, it's RFC 2 status. I want to move us to RFC 3, not this meeting, but I want to give a heads up that the intent is within the next couple of months, I would like to move it to RFC 3. So please go try it, go use it, see if it's got problems. Because once we've accepted it, it's going to be very hard to unaccept it. But it's all looking very good. There's been a lot of positive feedback on that pull request. Please do read through that if you're interested. Does anyone have any comments on one-off?
Yeah, just a question. You said to, go use it. What would you especially call it as like things that you would be looking for signal on, like places where you think it might encounter problems that would influence whether we continue it, or are there like known places that it would be good to pressure test it?
It's such a simple feature. I do not imagine it having any particular problems with the actual implementation. My personal concern is it the right solution? In particular, I think it would have been nice if like one-off was used for unions on the output types in the GraphQL as well, and have this like mirroring. So we'd have interfaces as they are currently, and then one-off for like everything else and mirror it on input. But that's not the case, and we probably don't want to introduce a third type of polymorphism on output. What we don't want to do is introduce one-off and then potentially later find a better input polymorphism type and then introduce that and have two different input polymorphism types. So if you can think of a better solution before we merge this would be a good time.
Yeah, but
I think that's the main thing.
Like the pattern like of one-off is something that people were anyway using already, just that they had to implement basically runtime validation in their resolvers. And this kind of encodes what people are doing anyways in the wider ecosystem, right? So I think it's...
So the outstanding concerns are more like language design and syntax and symmetry. I think that's the main one. It's like introduces a weird asymmetry between how we think about inputs and how we think about outputs, which is not, it's a little gross.
Yeah, I mean, back then when we like inspected all the proposals, there was one called Input Union, which actually looked fantastic until we actually tried to implement it, and that it had so many issues and would introduce like underscore fields on the input side and things like that. Like there's anyway not a symmetry between inputs and outputs. So there is a difference, and I think that's where one-off caters to.
And on the topic of the symmetry there, one of the reasons that I personally have dragged my heels on this a little bit is because I would like us to adopt the struct type. And I feel like the struct type would be a potential solution to this problem as well. Unfortunately, I haven't had enough time to push it through more rounds of going through the working group. The last feedback that we got from it was essentially that it solves too many problems and needs to refocus on exactly which problems it's solving. I think it naturally solves a lot of problems just because it's such a versatile piece of tech. But yeah, that is something that is worth considering at least. But there's no reason why one-off and struct couldn't coexist. That's totally fine. It's just something to be aware of. Okay, if there's no further comments, I guess the action on the working group is go out and use it. Go out and have a look at it, make sure that you're happy with it. Moving on to defining data collections. This has been a recurrent topic for a few meetings. For some reason, I had a local commit on this that I hadn't actually pushed, which caused me a lot of confusion when I represented this last time. But the changes that were suggested, i.e. the removal of the ordering from this first pull request, have been done. So this is just me saying that I think it's ready. So that's on pull request 1102 of the spec. It just defines the data types. I don't think there's any need to go into any more detail, unless anyone has any questions. No, so that was more of just an update about that. Moving on, we're then on to extensions, adding extensions to the request. This was split into two pull requests, one of which has been merged. So we merged a pull request that defined the names for all of the parameters of a GraphQL request. Schema, document, operation name, variable values, initial value, and extensions. That has now been merged. So this pull request is now purely, should we add this additional definition of extensions? Now, as a reminder for the group, the reason that this exists is, or that this is being proposed, is that specifications such as the GraphQL over HTTP specification, and also other specs like GraphQL over WebSockets, GraphQL over SSE, GraphQL over basically any other transport or any other encoding, will have this common concern, which is talking about extensions. And though the GraphQL spec does not assign any like behavior to extensions, because it's a common property, I felt like it would make sense to actually define it in the main spec so that then all of the other subspecs effectively could reference this central idea. So all it is literally saying that there may or may not be an extensions property, and if there is one, it should be a map, i.e. an object. That's it. No other requirements placed on it. So I personally think this would be a good addition. It is currently RFC 1. So I'd love to see this adopted. Does anyone else have any feedback?
Do we want maybe to have different names for different subspecs? Like, because we own the different subspecs. So if we're saying there is a WebSocket and HTTP and something else, there's a tiny chance that there is some like overlap between both, or if someone else want to use something in extensions. Like, question is, do we want to reserve namespaces for subspecs? Like if we already know the number of subspecs we have, we could do something like that, right?
On the extensions property, you mean? Like in the extensions map?
Yeah, either inside the extensions or maybe at the upper level, I was thinking, because extension would be like for the user, you get extensions, you can do whatever you want inside. And we, for the specs, we get to reserve other namespaces, and we are sure that no name clash is never going to happen.
Yeah, but that's already given, right? You cannot just introduce any. We define that also for error, right? That actually, if you want to have an error code, it needs to be going in extensions. Because like there was a custom pattern that people introduced top level properties. But it's actually this.
But that's forbidden for people, but is that forbidden for specification authors?
It's a good question. So effectively, where I stand on this topic is the top level fields are reserved by effectively the GraphQL Foundation. So we can add stuff in the GraphQL spec at that top level. And if we are the maintainer of, for example, GraphQL over HTTP, then we may add additional top level fields that make sense for HTTP. And because the same people tend to work on both projects, we will know not to have them overlap. So I don't think we need to worry too much there. If it comes to other implementations like GraphQL over UDP or something, whatever it is that you want to do, that is a community spec, then I think if they wanted to add any top level properties, they are totally fine doing so because it's their spec, but they risk conflict. So we would strongly encourage that they just put their stuff into extensions. And in general, as I've got in the note here, it's recommended that implementers use prefixes in extensions to avoid conflicts with other implementers. It's kind of left as a job to the implementer, like you should use a prefix here. Of course, that's not going to prevent conflicts. There is no registry of prefixes, but hopefully it will reduce them.
Yeah, also it's suggested you kind of namespace the your settings, right? Don't have like 15 top level extension, like on the top level extension map your properties, but have basically another map where you add your props.
I guess one of the reasons we don't want to introduce top-level namespace for HTTP, for an example, is that everybody is already using extensions for persisted queries, and we don't want to change that.
Yeah, that's one area exactly where people have top-level properties. We also did that, like in our implementation. And now we have actually the specification that introduces another, and there you can see the collision potential. So
yeah, my opinion on this is once something is an official GraphQL Foundation spec, it should not specify things inside of extensions. Everything inside of extensions is reserved for everyone else to use. So our implementation of persisted documents does have a top level key. I think it's just ID actually.
Document ID.
Yeah, document ID, that's the one.
Oh, okay.
But yeah.
Gotcha.
Okay, great. Michael, that suggestion that you said about having objects inside, I think that is something that's been mentioned a few times and is definitely something we should do, but it's not something that's in my current copy. So if you'd like to recommend that instead as an alternative to my note, that would be a great note on the pull request.
Okay.
Okay, perfect. Right. Well, I guess we're on to the bit that everyone's here for. Let's talk about semantic nullability schema. So I apologize to those of you who have already seen these slides from the semantic nullability working group. I am going to attempt to share my screen. This here. Okay, you should see semantic nullability schema. I'm going to assume that's okay because I've heard nothing else.
Yep.
Perfect. So this is effectively a summary of where we are on the semantic nullability front. It's a summary of where we've got to, and also a talk about where we might go from here. So very much a recap.
1 second, Benji. Martin, can you mute yourself? We hear you typing.
Perfect. Semantic nullability schema, true nullability indication for the simplest and the most advanced GraphQL clients. So nullability, it all comes down to error handling. Imagine you've got a schema, you've got users, and your users belong to organizations. You might define your schema in this way, that a user has an organization, for sure. Every user belongs to an organization, thus organization is non-nullable. But imagine that you're loading organizations from a different microservice and that service goes down. And now you've got an error there. If that throws an error and it's non-nullable, then currently that would blow up any selection set that is querying that type. And now we can't tell anything about the user at all, just because we can't tell what organization they're in. And possibly the error will burble further through our query. So to handle this, we make it so that organization is nullable. Yeah, now it's an error boundary and the null will stop at that position and we can still tell what that user's email is and so on. But now it looks like users may or may not actually belong to an organization. We're telling people that this is actually nullable. Is it okay for a user to exist without an organization? The combination that we've done currently of error boundaries with nullability is not always what we want. So really, it comes down to two different types of clients. Traditional clients look at the query that they've written. They look at the types that are in the schema, and they know how to type the data by combining these two. And they generate something like this from maybe code generation. But here, because the organization is nullable when we requested it from the query over here, we have a maybe. And we now know that our client code has to handle this maybe. Welcome, Lee. So even though they know that this null shouldn't happen unless something goes wrong on the organization service, they still have to handle this because the types say so. Now, error handling clients want to look at the response holistically, factoring in errors into their interpretation. They maybe know how to tie the path of the error back to the position that it happened at and do something special. Maybe they do it so that when you read this property, an error gets thrown. And maybe if you're doing that in, let's say, React, you could use an error boundary to capture this. So what they want to know is that a user will always have an organization unless an error happens. They don't want nulls to bubble, and they want to know that the true nullability in the schema, they want to know that a user will always have an organization unless an error happens. So it all comes down to two modes. Let's call the current way that GraphQL works the traditional mode and rename what we currently call non-nullable to be strictly non-nullable, since there will never be a null in that position. Even if an error happens, the null will bubble to make sure that a null cannot happen there. Let's call types that are null only when a matching error can be found in the errors array, semantically non-nullable. So these can have a null there, but only if an error happens. And let's introduce a new mode to GraphQL where we disable null bubbling entirely. No more null bubbling in this mode. And we'll call it, and we may want to iterate on this name, bike shed alert, no null bubbling mode. Whenever an error or a null occurs in a non-nullable position in this mode, the position will become null anyway, and it won't affect the parent selection sets. It won't blow up, it won't bubble. But an error with a matching path will be added to the errors array. So with no null bubbling mode, all of the existing strictly non-nullable positions are now semantically non-nullable. There are no strictly non-nullable positions. Anything that's strictly non-nullable can still error. And if it does error, it will now become null. So it's now semantically non-null effectively. With no null bubbling, there is only semantic non-nullability. There is no observable difference between a strictly or a semantically non-nullable type. Both may produce an error and result in a null, and neither will be null without there being an error. Now, the problem here all comes down to syntax. The GraphQL SDL is used both when writing schemas and to represent the schema when developing client applications. We need a way of representing these two types of non-nullability in SDL. But a vast number of GraphQL documents already exist in the world. Schemas are composed from multiple SDL files quite often, some of which schema authors may not even control. They might be mixing in SDL from remote sources. Clients might have their own schema extensions that they've written in their own little SDL files locally. SDL is also used by tooling for type generation and various other things. There's huge swathes of documentation that talks about how GraphQL SDL works and what the bang character means, for example. So we can't just change the meaning of existing syntax, or can we? Maybe if we do it locally within each document, we can. From a schema point of view, what really matters is the actual types that exist in memory and what is represented in the introspection results. The SDL is not a runtime concern. So it all comes down to documents. Introducing a new idea, a pragma. We can introduce a pragma at the top of a document, pragma semantic nullability. And if we do that at the top of a GraphQL document, then we can change the meaning of the syntax in that document and only that document. So with semantic nullability pragma in place, we can make it so that semantic non-nullable types are represented with a bang, and let's say strictly non-nullable types are represented with a double bang, something like this. So we've got our exclamation point that we wanted in organizational this time, and now we've got a double bang on ID. Migration is easy and handled on a document by document basis. We just add pragma semantic nullability to the top of the document, and we just perform a global find and replace every bang for a double bang. Done. Easy. There's an example in Vim. Other editors exist. When a client in traditional mode introspects a schema, it will see only strict non-nullability, and we'll be able to represent it with traditional SDL without the pragma. And so it will see exactly what it's always seen in the past. The bang character represents strictly non-null, and that's the only thing that it can see. When a client in no null bubbling mode introspects the schema, it will see by default only semantic non-nullability. And because, as we mentioned before, everything in no null bubbling mode becomes semantically non-nullable. So we can represent that SDL with pragma semantic nullability, and we only need to see the singular bang. We don't need to worry about double bang. There's a little bit of iffiness here for inputs if you're paying very close attention. In either mode, a client may request from introspection the true nullability of the schema, in which case it would need to represent the schema with the pragma, and it would use both the bang and the double bang characters. And this would likely be your preference if you have both types of clients, both an older client and a new error handling client. Some bike shedding for a moment. With this pragma, we can change syntax. So we could use option 1, which I've outlined so far, or we could use option 2, which Lee proposed before and is well liked. It's where we have a question mark to represent that something is nullable. We have the unadorned type to represent that something is semantically non-nullable, and the bang to represent that something is strictly non-nullable. And this is very natural. Option 2 is very natural for people. But I still posit that it is problematic. The nullable by default, I think, should still hold. It's safe to move in this direction down through your types. So if you start with a nullable type, you can then make it semantically non-nullable. This is for output types. You can make it semantically non-nullable without it being a breaking change. and something that's semantically non-nullable, you can make strictly non-nullable without it being a breaking change. And it's clear that you can do that by adding bangs in this direction. Whereas if we default to unadorned being this middle position, then movement to question mark wouldn't then allow, or it would be movement to question mark would be a breaking change, because now that position can have a null without an error. Also, just thinking in terms of the future, we could preserve the question mark operator, which may be useful for other things. So this is my opinion on why I personally prefer option 1, but option 2, I think a lot of people are more keen on. So it all comes down to error handling, 2 types of client, 2 modes, per document syntax, and representation and introspection. Now, this is very much just built on everyone's ideas and work over the last like 3-4 years, especially the people in the semantic nullability working group. We have a more full proposal. It's in a discussion on the nullability working group number 58. But we just wanted to bring this, present it to you as this is the thing that we're currently working on and thinking about, and to generally gather some feedback from the group. So does anyone like to feed in?
Very exciting progress. Couple high-level thoughts. One is, okay, I think we're going to lose people on the boundary between like these terminology. The terminology matters here because we have to teach non-core contributing users of GraphQL why there are like 2 variants of nullable. And so there's like a learning curve education problem, and we want to pave paths to reasonable defaults. I don't have any good suggestions there. I just sense that there's more work to be done to get this in an explainable state. Because even though I have been steeped in this problem with you, I still find myself occasionally getting lost on exactly the difference between a semantic and a strict null versus non-null. The other thought is I am wary of this being a document thing, like a pragma in a document makes sense if a document is always the source of truth for a schema, but it is not always the source of truth for the schema. In many cases, a GraphQL document is a serialization of a schema, and the schema just exists. You can introspect it, and maybe these are just like 2 different serializations. You can serialize with this pragma, or you could serialize without. But that also, I think, is like ripe for potential confusion of like, what does it mean if you never serialize it in the first place? And the only way you ever interact with it is via introspection, then like, how do you discern these states?
Okay, I'll answer your second point first. Yes, so in introspection, we have effectively, it follows the proposal that I raised, the semantic non-null type. So it just would use that. So essentially, rather than having just non_null as one of the kinds, we would also have semantic non-null. And then there is the subtlety that I introduced in the slides, which is effectively, if you don't specifically say, tell me the true nullability, and you are in traditional mode, then we just drop out the semantic non-nulls. So basically, clients would only have to deal with one type of nullability. Whether that be strict or semantic is dependent on whether they are in no null bubbling mode or traditional mode. But for general GraphQL consumers, they shouldn't have to worry too much about it, and they can just think of it as non-nullable, I think. And that's one of the big differences here. We're not saying that most people would need to deal with this. The schema authors definitely would. And to be clear, all of this is composable directly through library mode. It's not gated on, you don't even need to support SDL in your server for this to work. Like, you just, instead of doing new GraphQL non-null, you do new GraphQL semantic non-null when you wrap the type. So yeah, the SDL is just a serialization that represents this. The reason to introduce it is we need something that can change the meaning of the characters that we're using. And if we do that on a global schema-wide basis, then it would affect every document that is consumed, including things like local client extensions. And it would make, I think, migration to it really challenging. So by doing it on the document basis, we can do a little stepwise movement to it. And it makes the transition to it much easier. And it also means that we're not just invalidating all previous documentation that has been written about GraphQL. Your first point, I think I may have covered a little bit as well, which is basically consumers shouldn't need to worry about the two different types. And I think also broadly, this new style will be broadly consumed by really intelligent clients like Relay, like Apollo, and various others. So end users may not even need to worry too much about this. The schema designers will, but end users may not. So if you opt into, let's say, Relay having throw when you read from a field that raises an error, it allows the user to have more things just appear as this will never be null. If I read from it and it would have been null, I'll get an error thrown instead. So I think the number of people we need to educate is hopefully smaller, I hope.
I'll also say just because you pose the bike shedding syntax thing as Benji's pitch versus Lee's pitch is, I find the argument of the simplest thing is the most permissive type, like the widest type is the easiest one to write down. I find that argument quite persuasive. So just for the record.
I think the main argument around that should be, are things nullable by default? And I personally still think that they should be nullable by default. That's the thing that swings me most strongly towards option 1. But I do agree that the syntax for option 2 is nicer.
Yeah, but I also agree with option 1. Like it's less impact that we would have on the ecosystem.
And it's less impact for the server side, but for the clients, I have definitely seen some clients like doing guesses and assumptions about a type when it's nullable. You know, you have a server, everything is nullable by default, but you do a query and it's never null. So I've seen some client developers, including myself, in my early GraphQL days, doing the assumption that, you know, it's never going to be null. And so I just force unwrap this and I write my UI like this. And so even if technically it's not a breaking change, you end up in a situation where your clients just crash because the developer at the other end made a guess about it. So I'm going to challenge a little bit the breaking change here, because I think what I really want as a client is the most information about my schema and about the types I can get. And if something is never null and the server tells me it's nullable, it kind of breaks, you know, that trust I have in the schema, because it feels like the server is a bit lying to me or something like this.
There was a discussion. Yeah, sorry. But there was a discussion like taking something like TypeScript, where you say it's either a non-null or it's an error, and it doesn't convey that. I agree. Sorry.
I was going to toss out a likely bad idea, but on the theme of bike shedding, just to add it to your list, Benji. Imagine a third column to your table of options, where there exists no unadorned type in this new way. There is the name of the type followed by a question mark for nullable, the name of the type followed by exclamation point for non-nullable, and double exclamation point for this weird strict non-nullable that we want to move people away from. And in that sense, because so in an earlier version of this that I had pitched, I introduced the concept of ambiguously null, which is to say in the unadorned type is actually likely what happened is the server engineer never really thought that hard about whether it's null or not. Perhaps their backend is in Python or Ruby or some language that just like doesn't think that hard about nulls, and they just didn't define it. Certainly that was a very real truism for early Facebook, which was PHP based, which had no concept of nullability baked into the language. So people just exposed fields. And what Martin said was very true, which is many of them were in practice non-nullable. Clients found it extremely annoying and would just assume that they were non-nullable. And you would have these like blue moon events where, you know, of the 5 fields on this type, 4 of them are actually non-nullable on the server. The 5th one is technically nullable, but only in rare edge case scenarios. And the client developers, you'd be like, these are all non-nullable, and then we'd have a null pointer exception, and it crashed an app, and it caused a sev. So I do like the idea of making it explicit. Like part of the hope of this is to remove the ambiguous null and say, hey, server engineer, as you're defining your schema, are you sure this is a non-nullable type, right? That's the nice part about having that be an opt-in, is it makes you really think explicitly, oh yeah, I know for sure that this cannot be null, which is backwards from how most type systems work. But the opt-in part is the secret sauce. It's part of why that is a good thing.
I immediately liked that proposal, the proposal to add a bang in the middle, until I realized that it then means that every single type that we define anywhere, including list types,
that's why it's a bad idea. Yeah,
is going to have us. But like, yeah, if we weren't worried about that, great. It's a brilliant solution. So one of the things I wanted to circle back to, because I'm sure syntax is going to be the main hang up for this, is, as I was saying in the talk, in the no null bubbling mode, there is really only 2 types, which is nullable and semantically non-nullable. So if we were to change to use the question mark, we effectively would have in traditional mode, you've got int and int bang, and in no null bubbling mode, you've got int question mark and int. And I think that is more confusing than preserving something. So yeah, I find that particularly problematic. I find that really confusing. There was another thing I was going to say, but I've forgotten it.
I agree. Just for the sake of having the rebooting everybody's context, the original argument for this option 2 of using the question mark was thinking from an ergonomics point of view, what will be the most common type? And then most folks believe, and most type systems work this way, the most common type is the semantically non-null. That is like, it describes the set of types, which are integers. And then in addition to that, you can say it's an integer or it's the null type. And that is a more complicated type and therefore an opt-in thing. But I think broadly there's agreement that GraphQL or any kind of API surface needs to be particularly cautious about that boundary. So if we think like 80+% of fields are going to be the semantically non-null, that's going to be the default. That was sort of the argument for why option 2 was interesting, is like, okay, well, in that case, most types are unadorned. There aren't extra characters that you have to type. And only in the nullable case, which we imagine will be the less likely one, you type this, and it is familiar. It feels similar to other familiar type systems. Okay, I still think option 3 is probably not a good idea because it puts an adorned character on every single type. But my critique of option 1 from early on was, okay, well, if we think semantically non-null is going to be the most common type, then Actually, the kind of same critique applies, right? Like we would imagine that you're going to see exclamation points all over the place. And so I'm trying not, I'm not, to be clear, I'm not arguing for option 3, but if you're going to look at that, you might say, well, like, wow, well, if you're going to put on the lion's share of types, you're going to put an adorned character on there anyhow. And then you see one without an adorned character, and you're like, well, what is that? If this thing is special because it has an exclamation point, what is that? That's not special. And kind of what we're saying is like there exists no special, or maybe this is my spicy take, because Benji, I agree, you sort of want to start at a basis that's most allowing, which is the nullable type, and then require careful thought to go narrower from there, because you're removing optionality. But maybe really what we want is for server engineers to just kind of pick one or the other, like just make it an intentional choice. And perhaps that doesn't have to be a syntax thing. Perhaps that is actually like an underlying library API level thing. But maybe that's my pseudo argument for this option 3 is you would then see some sort of syntactical thing on every type in this particular mode. Like if you opt into this mode, you always get the information on nullable or not nullable, even though it is slightly annoying.
I was just thinking there's a lot of stuff hanging on like what we think the distribution of field types is going to be in this end state, but that also seems like something we could maybe get data on. So for example, I can do some analysis of Meta's schema to see like what percentage of resolvers are nullable. It's not a perfect assessment of like what the ideal schema design would be. Thinking especially about things like forward compatibility, right? Like you may want something to be semantically nullable, even if it's always going to return something today because you want to preserve option value for deprecating that or whatever. But that could be a baseline. I wonder if there are other meaning like statistically significantly large schemas that could do a similar type of analysis. I don't know if anyone in this room or knows someone who is in a position to do something like that.
What does a GitHub schema say? It's a big public schema.
I think we need a little bit more insight though. We need to know like under the hood, what are the types of those resolvers, for example? And I guess I don't know, do they do nullable by default?
I think this is definitely a key question though, which is because quite a few people have said that non-nullable by default is like non-nullable is semantically non-nullable is most likely to be the more popular type. But I'm not 100% sure that that is the case. I wouldn't be surprised if it was like 50-50 or maybe 60-40 towards it. I'd be surprised if it was like 80-20. Excluding Facebook from this because Facebook does not like nulls and avoids nulls wherever possible. But yeah, it's very common. I mean, even if you look at like database design, like things are nullable by default. So therefore, the data that you use with an ORM is nullable by default, and so on and so forth. Taking us off this topic for a moment.
There's one thing I wanted to add on there, which is some early looking I did at these numbers internally actually does favor a great deal of nullability for exactly the reason Benji pointed out, is that some of our underlying layers, like our ORM type layers, do sort of default to nullability for a couple of reasons. One being, as those fields are added incrementally, there's like a migration. So like, oh, this field didn't exist in the past, now it does. Well, that's going to have to be nullable because it didn't always exist. So I haven't sort of dug into the root causes of all of the broader trends, but there is, as you point out, sort of actually, well, despite what you said, Facebook does not like nulls. Like when I went, that's sort of my assumption too, but when I went to look at it, there actually are, like, it is, the nullability is quite common. And those are some of the dynamics that I expect lead to that outcome. So that may influence things.
Super interesting.
Yeah. Awesome. And yeah, as you grow your schema, you're going to have like this data's not populated yet. So for sure, null is useful in those places. What I wanted to circle back to is a slightly unsolved problem on this, which is input types. We've talked about there being nullable, semantically non-nullable in the middle, and then strictly non-nullable on the far side. But for input types, there is no like semantically non-nullable. Like it's either nullable or it's not nullable. We do potentially in the future maybe want to think about the difference between nullable and optional, but that is a separate concern, and I don't think it ties into the semantically non-nullable thing. So if we were to use, for example, double bang to represent a strictly non-nullable thing when this pragma is enabled, does that mean that every single input position that was non-nullable would now have a double bang? Does it mean that we would make it so that actually a bang is fine for input and we'd always interpret it as strictly and we don't care which one you go for? Would we reserve one or the other for the future? Would we want to mirror this so that if we were to introduce something like the struct type, that actually the bang would make sense because it needs to be consistent on both input and output and mean the same thing? So we would use the double bang, for example. Like there's a lot of questions around that to my mind that I haven't actually answered.
For what it's worth, I think input types are sufficiently different that the scope of this should not impact input types. Like I would think it would be quite confusing if we were to change non-nullable input types to use double bang. Or that we would need to introduce some variant of non-nullable inputs that would require a differentiation of one bang or two bangs or something else. Because on the input side, I think the nullability story is far simpler. There's still some nuance there, like what's the difference between optional versus required versus nullable versus non-nullable. We've like flattened that, which is a choice, and it simplifies some things and complicates others. But aside from that, it's just like here exists an input or something, and if it says it's non-null, then you have to provide it, and you have to provide it with a value that isn't null. It's a lot easier to understand. And there aren't these scenarios like error conditions that could error it out or something like that we have to work around. So yeah, my bid is to leave the input types alone for this change.
I guess the question is there a future where there are types that can operate in both positions as input and output, in which case we may lead ourselves into a corner where there's like not a sensible way to, like if we're saying they continue to diverge.
I guess maybe the frame would be, okay, imagine you have a struct type or something where you can use it both in an input position and an output position. So what would be the difference between a semantic non-null and a strict non-null output type used in an input position? I haven't thought about it that hard, but my suspicion would be there's no differentiation on the input side. On the input side, they work exactly the same. It's an input field. It is non-null. That means it's required and you have to give it, and it can't be a null value, which means for those, like it could be the case that when we go down that path of shared types across input and output, single bang, double bang on the output side has a meaningful difference. On the input side, doesn't matter. And in that scenario, because our input types can't be used as output types today, we can just kind of leave them be. But
Jeff, you've had your hand up for a while.
Oh yeah, sorry.
If we wanted to close out this notion about this, that'll be fine. I'm kind of bringing up something that changes the subject a little bit, so I'm happy to let this kind of breathe, and then when it feels right, I'm happy to raise my hand again.
Okay, sure. Yeah, I just wanted to say, I think you're right, Lee, and I think that actually the bang and the double bang when used in an input would be just seen as the same. My main issue for this came from migration. it's very easy to just replace all bangs with double bangs and then go from there, introducing new ones. And if we say, oh, in input positions, now we need a parser that knows whether it's an input position or not, and it becomes more complicated. But separately, if the pragma exists, then what we're saying is the pragma changes the meaning of the bang and it introduces the double bang. So now when we read that for an input position, like the parser doesn't know it's an input position, right? It just knows it's a token or whatever. Is that going to be problematic? And I think the solution that you've said, which is basically, we don't care. It doesn't matter if it's a bang or a double bang, if it's input, we just treat it the same. I think that that's the correct solution. That's the one that I was leaning to personally. But I wanted to, like, one of the concerns I have there is like preserve option value, right? If there is this differential syntax, would it ever be useful? Is it something we ever want to represent? But I think you're right. Just smush them together and it's fine. When we print out, we would probably print with only one bang, but we'll accept double bang as input.
Oh, I see what you're saying. Yeah, that seems potentially fine. Or usually when writing grammars, if your goal is option value, you want to be as restrictive as possible. So my sense would be you would want to write the parsing grammar such that you can only use this double exclamation point in the context of an output type. Which might make the parser slightly more complicated, but that would, if the goal is preserving option value, that would then mean people can't now all of a sudden type single exclamation point, double exclamation point in the context of an input type. So that later, if you're like, oh, whoops, actually, this distinction is super helpful for this new thing we're building. And oh no, now you can't actually do it because we've let people use both of them interchangeably up until now.
Yeah, that was my concern, but also I can't imagine a world where that situation comes up. So I'm kind of okay with going with the easy route, which is allowing either because it makes migration easier. And I guess more consistent.
Yeah, also the syntax tree, like at the moment, we don't distinguish on the parser level in the syntax tree between input and output types. So
Yeah,
then we would like
it would need to be a
either,
validation rule.
yeah.
But the parses a tree, and you know the parent node of the tree. So I'm pretty confident that it would be easy to make the parser work. But I understand what you're saying for migrate. Like if the migration you really want to do is write a global regular expression search and replace that replaces singles with doubles, then like, yeah, that will break if some of those are within an input type. But I don't know, like maybe we want to do something like I imagine the exclamation point is whatever the old syntax thing is. And we introduce a new kind of syntax, which is double exclamation point. And that kind of syntax is only allowed in the context of an output type.
Yeah, I'm okay with that. I mean, to be honest, using a piece of tooling that does basic GraphQL parsing to introduce extra exclamation points is fine. It's not a big deal.
Yeah, I think a regular expression fails on like exclamation points and comments, for example, anyway. So
True. Very true.
or string literals,
Jeff.
I guess.
Read my mind. All right. I wanted to zoom in on the pragma concept a bit. And the reason I think it's really sound, honestly, and a really creative way to solve the problem of how do you go ahead and parse this. But I also am interested not just in it as a solution to, or as part of the solution, but as a canary or a sign of how we as a community see the future of GraphQL. And if we were to stretch our imaginations a bit, like what other pragma might we foresee in the future? I think maybe it gives us a window into how we, what we choose for this particular problem today. and how it leads the community into tomorrow. For example, like, no matter what, there's a breaking change here, right? There's something that if somebody wants to go ahead and opt into this new behavior, they have to do it. And if we as a community are still doing this in 10 years, is that what we want? Versus like, is there an upgrade path here where we say, okay, we flip a switch sometime in the future to say, now this is this is the default behavior, and now you have to use a pragma to opt out, for example. And if so, what does that mean about it? Does that imply versioning? And the reason why I ask that is then when somebody's looking at a GraphQL snippet, say somebody who's not a GraphQL enthusiast, but somebody who uses GraphQL at work, they didn't decide to use it, but they're using it anyway, and they're moderately happy with it or whatever, but they're not an enthusiast. When they see a snippet of GraphQL code that doesn't have a pragma in it, when they see syntax, how can they guess at its meaning now? Especially when viewing old snippets. Would it be simpler to consider a versioning scheme, for example? And these are open-ended questions, like the notion of like, how do we make sure that somebody looking at a snippet of a GraphQL document out of context or something like that can grasp its meaning, especially when we're getting deep into, say, like an educational material and want to show like a snippet, like how do we make sure that that's in people's working memory, that they're looking at the syntax that matches the meaning that they're already seated to understand? Or somebody who hasn't used GraphQL in a while goes ahead and sees a question mark or a double bang and is thrown for a loop a little bit. So what's the elevator pitch here that we're saying? Is this pragma being specific to a specific feature? Or are we considering this as part of a larger way of how we kind of lift and shift the GraphQL community to accept changes longer term that may not be backwards compatible, but are ultimately good hygiene, good healthy practices for today's challenges? And so I would encourage us to kind of think about this problem, not just from how it solves nullability, but how it solves kind of perhaps a deeper rooted issue in GraphQL as a language and as a community, and also how we bring people along with us. And so it's a big question, but yeah, I don't know. Just, I was wondering, because I haven't been steeped in the nullability working group, like what the group has speculated on and how this might, carry forward into the future.
So I'll just weigh in with a couple of my early opinions since I named the feature. My intent for pragma is effectively to indicate breaking syntactic changes, and that would be its only use. So it would not be used for just indicating feature capabilities. That's much better suited to something like directives or metadata, whatever we solve on that front. As regards versioning, I think that GraphQL requires a non-linear versioning system. So as we introduce new features like incremental delivery or subscriptions, which obviously we added ages ago, you should be able to say which features you support. And it shouldn't be like, oh, this is, October 2023 version of GraphQL, so therefore it supports everything in this spec. I think the ability to opt in to certain things, like Michael's always doing with Hot Chocolate, adding all the latest features, being able to indicate that is really valuable. I don't think Pragma's for that. Pragma as well, as currently specified, which it really isn't, is like literally the keyword Pragma and then a value for it, which leaves space for us to be able to introduce later a Pragma with arguments. It would be that you need to add a Pragma that has like pragma args would be the next pragma, and then you could introduce one that has arguments afterwards. But like that's how it's currently specified. We could make it so that we support them out of the box. But yeah, that's all for me.
Yeah, I think there's a good point here around like if we need, if there's yet another a second thing that we think, oh, we really need to make some kind of syntactic change to, and it is similarly a thing that we see as like this should be the default. This is what we want everyone to be using. Then like over time, the end state is going to be, the expectation is that every schema document has this, list of n different pragmas at the head of it to specify all the features, which we think should be default. So like, I wonder if maybe there's another way, which is like there's pragmas for things that are like experimental and things that we do think are like a la carte items. And then there are things that are like, no, this is just like the language version that you're on. And this should be the default now. And when we want to switch from an opt-in to a default, it operates at a like versioning level. But I guess you need something similar syntactically to say what version this document is assuming.
There's okay, I have two separate thoughts. One, is it actually the case of what we want to do is talk about this is the pragma changes the way that you parse a document, or the syntax, or otherwise is what we're saying the pragma is how you interpret the document. Like should we have one grammar that describes GraphQL, and depending on what pragmas you have, you need to interpret that grammar in a particular way, where we say like, hey, if you see the exclamation point after a type, which by the way parsed just fine before, then here's how you need to interpret it now versus later. Or this new double bang, what happens if you put a double bang in your document and you don't include the pragma? Is it a parse error or vice versa, right? Does it literally fail to parse? Or does it parse and then say, hey, we actually we can't interpret this document correctly because you've included this bit of syntax, but you haven't included that pragma, and like it is in an undefined state, like it's a validation error or something. Is it at parse syntax time, or is it post parse syntax? My bid would be post, because I imagine maintaining forks in the grammar will be very challenging. And especially if your sort of point of comparison is the use strict for JavaScript. Like JavaScript still has one grammar, and the use strict tells you how to interpret that grammar. Second thought, do we need pragma, or are these directives? Are these document directives? We don't have a concept of a document directive yet. We left space to do that, and then we omitted it in the meantime. But you can imagine us extending the grammar to say a file can begin with a list of directives, and then we'll continue with the definitions. And with that would give you single flags, which is just at name. It would give you arguments. It would give you the pieces that you need without having to introduce yet another kind. Or is there an explicit reason why directives does not solve this problem and we need a new thing?
Document directives, I think, would solve this problem. Yeah. Where would they be defined?
At the top of the file.
No, that's where they would be specified. That's where they would be used. Where would they actually be defined?
If it's like if it's a custom one, then you would have to define what it means below. Like it should be fine. There's no use.
They'd be built in, right? Like skip and include. So they would just be defined in the main spec. That's where they'd be.
If we have ones that are defined in the main spec, then that would be fine. But it would open the space for you to have custom ones where you could use it at the top. It defines the document, and then within the document, or maybe there's like another sidecar document, which you can cat or something, that shows you what they are. The quirk of that would be that if anyone is parsing their GraphQL by concatenating a bunch of files together and then parsing them, that would become a parse error because they would need to be literally the first things in the list. Pragma, I think, would have the same issue though. And then Martin made a good point in chat, which is, are these actually a document property or are these a schema property?
Yeah, I think I've used schema extensions as a way to put something global. But yeah, that wouldn't work for a single document. But if we are talking about changing the behavior of how you interpret the schema, some people do that today, which I think is not completely valid, because if you don't have a schema definition, you're not supposed to add extensions, but I've seen that.
I think one of the really key things about this latest proposal is that it is document-based and not schema-based. It's what allows us to have local schema extensions on the client that aren't affected by changing this global, what would be a global flag on the server side. I think without that, it's very hard to migrate to.
In this discussion of like directive or pragma, I think we've maybe lost track of, I think what I think is maybe a more interesting point is like, is this like, do we think like language versioning is like a more accurate way to describe what we're trying to do here? Or is this like an a la carte thing that we think you opt into, and that like that's the right mental model for it, and that there may be other a la carte things that you would also opt into that are similarly like language level breaking changes? I guess I am a little bit swayed by Jeff's prompt here that like this is more of like a V2 or 2028 edition when we finally land this change. And that this is the default that we think people would want to opt into, and that if we have future things like it, we wouldn't want you to have to opt into all of them in each document that you write.
I just think that's going to be really hard to do, to Benji's point about the non-linearity of versioning. And so far, we've had such a strong stance on non-breaking changes that we haven't had to go quite as far as this. But we need the ability to, because to be clear, we don't necessarily have to. Like, I think another version of this was a separate, like not using exclamation point for this at all, using a different syntax. That would still be a path, right? We could say exclamation point means strict non-nullability, and if you want semantic non-nullability, then you have to use some other character. That's still an open path for us. But if we think really strongly that like, no, we want to change what it means to have an exclamation point, then you have to have something that describes that. Part of what I like about having a rather than it being a pragma, having it be a directive which takes an argument, is you could have have a default that like if you omit it, this is the default, but if you include it, you can always set it to exactly the default. So you could imagine having like this strict non-nullability false, true, and like either version of the pragma style or the file level directive is valid. Because then that seems less problematic to me over time. Like it's not that crazy to say, hey, here exists this GraphQL document, and the very first thing you'll read at the top of the file is here's a handful of keys that help you understand how to interpret this. Like this is using strict mode and it's using this other thing. And it would be very good if we are very, very cautious about how we add to that list. But it doesn't seem that crazy to me that we would have this like configuration one at the top.
I guess we could, they don't have to be mutually exclusive either, right? You could say, oh, we have a sort of, feature per feature opt-in thing, and there's no notion of a true breaking change, but then there's like versions, which is like, here is the like convention as of 2025, here's the like default set of pragmas that you ought to be using. You can still opt in or out of them individually. But like, if you don't want to like individually enumerate all of them, you can just say, yes, I'm using all these features as specified in the edition 2025. Jeff?
Yeah, that will make sense. I'm just thinking back to the kind of origins of kind of this revival in the nullability renaissance here. And I think about the title of Stephen's talk, The $1 billion mistake or whatever. And the way that we've characterized this problem, it seems to me to stick out, though there are many different innovations and ways that we could make backwards incompatible or breaking grammar changes in GraphQL. This seems to be a unique problem, and unique in a lot of different ways, in the scope and scale of the problem and its implications for existing and future GraphQL implementations, right? And so the notion of expressing it as a pragma and being the first kind of like potentially the first kind of implementation of that language construct. It makes sense 100%, but it also like feels like, are we fixing the language knowing what we know now, or are we changing or like creating like a path towards gradual like implementation or adoption of a feature? And I think that distinction is really important to lock down, right? Are we like trying to say, hey, this is actually probably like the thing that we need to fix the most with the most urgency because it has such large implications, whereas anything else that might use a pragma might be more along the lines of what we're talking about. We want to kind of gradually implement change, allow people to opt in. But when I think about, again, like how we want to teach GraphQL and how the next generation of GraphQL users come along and interact with this, how do we make sure that we're, and Jordan, to your point, like having like kind of like a preferred set of pragma could be one way we do that, right? Where we kind of bring people along that way. But I guess I really want to press down on what it is that we're trying to do here from a conceptual point of view and kind of fit the solution to that along those boundaries, I guess.
But the question also is like, it's a pragma in the SDL, right? The SDL is not necessarily how people define their GraphQL schema. If you're having an implementation first server, your server could just have the defaults that we think are good, right? It's always like an implementation detail also of the server, how the defaults are set. And this is just the serialization of what the server did for choices in the end.
And to be clear, this is not a breaking change for an implementation first one, right? This is an introduction of a new kind of type called the semantic non-null, and the introduction of a new kind of operation execution time flag to provide, which is the non-null bubbling. And those do feel like they can be added without creating any breakingness. Is that right?
Actually, we didn't even introduce a semantic non-null. We introduced a strict non-null. So what non-null, the default thing, means in our server is basically what changes.
And yeah, it's non-breaking in both directions. So you can update to a newer client that, excuse me, a newer client that requests no null bubbling mode. And even if the server doesn't support it, it will still get back a response that it will understand. And similarly, the server can support the semantic nullability without clients that don't understand it getting confused. So yeah, it's fully compatible in all directions. What isn't necessarily compatible, though, is if a client that doesn't understand semantic nullability was to be given a document with either a pragma or a document level directive, which, to be honest, are just syntactically different ways of expressing kind of the same thing for this regard.
Oh, yeah. It just occurred to me that one nice thing about a document level directive is that it would be like a less catastrophic error, right? It would be like a this thing is not defined error rather than like I couldn't parse this error. Just occurred to me.
I don't think it will pass under current parsers.
Yeah, we don't have the concept of a document level directive yet, but
maybe I misunderstand what that means by document level directive.
Like starting a SDL with an @ symbol.
Yeah, that would be a parse error today.
I see. In the top scope, right?
I know we're at time. Benji, do you feel like you have what you need to make progress or bring? And maybe this was just an update, but you got what you need in order to take stuff back to the working group, nullability working group?
Yeah, it was, as you say, an update. It's the nullability working group reporting back to you and the rest of the group to get a general sense of what people feel. But yeah, I think still seems positive. I actually like the idea of going with the directive, document directive approach rather than a pragma, just because it's using something we've basically already got and just tweaking it a little bit. So I'm very much on board with that. I mean, essentially, it's just a pragma anyway, just with a different symbol. So I'm good with that. And I am still of the opinion that you first expressed, which is for inputs, treat bang and double bang as equivalent. I don't know whether we want to do anything special there. If you can come up with a use case where inputs might in the future, in 5 years, in 10 years time, need two different bangs, I'd love to hear it because it would give justification for actually putting effort into that. But I'm of the opinion, let's just smush them together. So yeah, I think those are the main outcomes.
One other quick question I'd have for this group is like, even all the ideas we've had are going to introduce a fair amount of churn somehow or another. And I just want to gut check, like, are people still feeling like this is an important enough problem that we should continue, even under the assumption that it will introduce some amount of churn? Or is there anyone here who's like, I just think this is not worth it? Unless we like could cut the churn by an order of magnitude, this whole thing is, destined for the scrap heap.
I do feel strongly that this is a problem we're solving. Like anytime you get a broad cross-section of the GraphQL user community and ask them what the most important thing is, they find some way to complain about how nullability works. And I do think that there's a path here. I appreciate that how we treat the STL is complicated. But the fact that the like no null bubbling thing is a opt-in only change by a client makes this like far less churn inducing. Like if we just like pushed a change that now every single client needs to be aware of a new behavior, that would be a mess. But because this is opt-in on a client side point of view, I'm less worried about just how much churn we're going to create. It seems like we're pretty dang close to a sweet spot of important problem we're solving and solution space that hits the right trade-off of meets the value while minimizing the churn.
One last question. This is going to be a lot of effort to write up. So do we feel that we're in a reasonably agreed position where it's worth expending that effort? Because honestly, I've got 25 open pull requests on the spec repo and I don't really need another one. So yeah, if it warrants more discussion and more thought for a while, then I'm more than happy to do that and put off actually writing up the spec changes.
Do we need some experimentations before we dive into the spec edits and everything?
I think the experimentations we've already been doing at the nullability working group, and I don't want to take us too much further over time, around the semantic non-null directive are still pretty much valid for testing out this. The actual behavior of the nullability lines up with the pull request that I raised on semantic nullability, semantic non-null type, like a year ago, whenever it was, just after GraphQL conf last year, actually. So I think it should align with that quite nicely.
Yeah, I think we have quite a few different clients and servers exploring this between Hot Chocolate, Grotz, Relay, www server at Meta, some native client stuff at Meta as well.
Benji, my advice to you is to try to hit a sweet spot between describing this well enough that it's concrete and people can give good feedback, while maybe stopping short of like thinking super hard about exact spec language. Perhaps like writing accurate grammar rules is still worthwhile. That's probably not the hard part.
I could probably raise a separate pull request that is just talking about adding document directives as well. Would that need a concrete like use case to go along with it?
This is the use case. Yeah, I think we would look at them as sort of like you know, here's two parts of an overall thing, but we've broken out into its pieces to make them easier to review. But like, I don't know, I don't see a world where we actually, I don't know, maybe document directives are independently useful enough, but it may
I've
be the
got
case
uses for them.
wait, yeah, maybe plenty of people will. But if we're dubious about that, then we can just like look at it and say, as soon as we're in a state where the like nullability in the SDL requires them, then we'll get them like tidied up and merged first.
Okay, awesome. Sounds good. I've got everything I need. Thank you very much for your fantastic input, everyone. Catch you next time.
Thank you, Benji.
Thank you all.